So today we're just going to look at a couple of examples for making tests about um, proportions. Okay. Now remember, this is called a hypothesis test or a significance test. You'll see it called both of those things. Um, Sometimes I don't think our book uses significance test as often, and so occasionally I've had students that when they get onto the AP exam, they're like, wait a minute, what the heck? It's the same thing. Okay. So this is one that I actually got from one of the videos on AP Central. The videos that are on there for statistics are generally pretty darn good. Um, they will typically use one problem for like 7 different videos, and so it gets a little old, but this is the problem that they were using. So let's take a look. So to investigate if high school students associate the color green with being more natural, whatever that means to them, researchers randomly selected 30 students from a local high school. Each student was asked to taste 2 cups of lemonade in random order and state which one tasted more natural. One of the cups was green and the other one was white. Unknown to the taste testers, both of the cups contained the same brand of lemonade. Of the 30 students, 18 of them stated that the lemonade in the green cup tasted more natural, and they had to make a choice. They couldn't. I've had students ask about this one. Could they have said they taste the same? No. You have to choose green or you had to choose white. You had to choose one of the other. So it's a forced decision. Um, is there, that's the wrong there, is there convincing statistical evidence that more than half of the students at this school would choose the green cup? Okay, so let's take a look at what are the different qualifications that we have to have. Yes, I know you haven't thought about this in almost a week, but what are the qualifications you have to have? What's one of them?
Random.
All right, so according to the problem, this is a random what? Sample. And we always have to write these out. What's the next thing we want to look for?
Independent.
Independence. So, can we know for sure that they're independent of each other?
No.
No. Does it seem reasonable that this would be independent based on the way that they're doing it, and what's the other thing we look for? Less than 10%. Did they tell us how many people are here?
No,
No. But
we can assume.
we'll assume. So we can't, know for certain here, but in order for us to do the problem, we're going to assume that 30 students is less than 10% of the entire high school population. So now, why is it that that goes to independence? Why is that part of independence? I mean, that is the rule, but why?
Is it because? Oh, you go.
No, you need to go.
Is it because if it's more than 10%, then there's more likely of a chance that the subjects could have some kind of similarities, or they could have some, some impact on each other.
Yeah. So it's no longer independent. So
Sorry. The way you said that was just funny. It was like in the
So,
definition.
so for example, on this, if let's assume that this is a large high school like there are around here, where there 3 or 4 thousand students, kind of thing. So if you get 30, and you really are doing a random sample, are you very likely to get, for example, a brother or sister of one of the other subjects? And they may have similar thoughts about, their parents may have taught them that green means natural, right? You have no way of knowing that. But if you you want to take a small enough sample to get what you want, but what's the other part that we need to do?
Has to be
Needs to be
greater.
represented.
The success and failure has to be greater than 10%.
Okay, so our expected successes and our expected failures have to be greater than 10.
Yes, sir.
So we're interested here in more than half, right? So our expected successes is going to be, well, 30 times 0.5, right? That's 15. That's greater than or equal to 10. And because it's the same calculation, and I don't want to do that again, the expected,
Or 18.
I'm sorry,
Why is it 30 students, not 18?
because that's the total number of students.
Oh, yeah.
I thought successes would be the 18 that stated it's.
So that's the observed successes, not the expected successes.
Oh, expected, right, okay.
Right? We want to have an expected value of greater than 10. Otherwise, we just don't have a big enough sample. Okay? And that's also going to be equal to our expected failures. So once we've tested all of that, then we say, okay, the conditions and assumptions have been met for what kind of a test?
Normal. Oh.
What's the name of this test?
More natural.
No. We're looking for, what are we testing for?
That's you mean the one we just did with the successes and failures?
The whole test.
Oh,
That's part of testing for, do we have a big enough sample?
yeah.
Okay, we haven't done this enough apparently. Assumptions have been met.
Choose a normal.
How many samples do we have here?
One.
Yeah, it's just one. We'll eventually get into two. A one sample z-test for proportions. Now, how do I know it's for proportions here? What is it we're trying to do?
Find the proportion of people that believe green is.
Right, we're going to test whether we believe that the proportion of the entire high school is going to be greater than 50%.
Yes.
All right, so let's let P equal the proportion of all students at this school so you've got to carefully identify what is your entire population, who would say that what?
They would choose the green cup.
What are they saying when they choose the green cup?
Tastes more
Lemonade
natural.
and the green.
Yeah, that the lemonade in the green cup tastes more natural. And whenever possible, remember, try to pair it. Try to talk about it in exactly the same terms that they do. Okay. So that's all the preliminary stuff. And you've always got to get all of that done before you jump in. All right, so what is our null hypothesis here?
Oh, this is the. That's like.
What is it that they're purporting? What are what are what are we trying to decide?
More than half the
Yeah.
students at the school would choose the green color.
So the null hypothesis is we don't believe that.
Okay.
Oh, so less than half.
Not quite.
Oh, not half. Oh wait. 'Cause it's like
You guys
don't say-
are trying to make this too hard. The null hypothesis is that P is a half.
Oh.
We're going to test to see if their assertion or our question is that it's more than half. So our alternative hypothesis, I always put an equal sign and I shouldn't, is that P is greater than a half. Because it does say more than half.
So the alternate hypothesis is what they give us in the problem.
Yeah, that's what we're trying to test for. And the null hypothesis is you got to get me off of this. I believe that it's a half. It's the skeptic, right? It is in the jury trial, what is the assumption when you start? That they're not guilty,
Yeah.
right? You have to change my mind from that.
Right.
So it's like the bare minimum though.
Right. Okay. And we'll look at another example in a minute where they ask, we believe, test, is it different than this proportion that you're given as opposed to greater than? Your null hypothesis is always going to be an equal to.
Okay.
Someone says, this is where our starting point is going to be. Change my mind. Okay? All right. So let's do all the work for the z-test here. So what is the proportion that we actually observed? Well, it was 18 out of 30, which is 0.6. So, what?
Oh wait.
That was some quick math right there.
Oh, that's, I just divided them both by 3. And it was 6/10. So it's 60 out of 100.
Okay, that makes it simple.
Yeah, if you divide them both by 6, it doesn't work as fast. Right?
Right.
Let me get this. I have my numbers worked out. Not that one. This one. So our z-score is going to be what we observed minus what it's supposed to be, divided by, well, we need the standard deviation. So our standard deviation is the square root of 0.5 times q, which will also be 0.5,
So 30.
over 30. And this comes out to be 1.095. So we want, what's the probability that I've got some value that's greater than 1.095, where we have a normal distribution and we're looking at z-scores. So on your calculator, so we're doing a normal distribution. So the mean is 0, the standard deviation is 1. What is the probability that we have greater than, mine's already set on greater than 1.095?
About 13.7%.
Yeah, So is that a crazy low percentage?
No.
No. Remember, and we'll talk more about this in future chapters, but generally speaking, you're like, okay, 5% is kind of where you start to get, yeah, that could happen, but it's not very likely. That's a sort of a typical dividing point. The other thing you could talk about is how many standard deviations is this above the mean? Is that what you were?
Yeah, that's what I was gonna want to ask if, I forgot we could do either or, but, yeah, it's not 2 standard deviations, so therefore it's not to the point where we should be like, kinda, surprised.
Yeah, we shouldn't be skeptical.
Skeptical.
This is this is unusual, but not crazy unusual. So our P-score is too high. And we normally do our P-scores as, a decimal, but you can do it as a percentage. Either one is fine. So what you would say would be something like this. With a P-score of 0.137, we can either reject the null or we can fail to reject the null. We never accept the null, right? So we fail to reject the null. You always start by talking about, am I going to reject the null or am I going to fail to reject the null? That's always your first thought. Reject it, fail to reject it. And then talk about their assertion. So, you didn't change my mind, right? So, the question was, is there convincing statistical evidence that more than half of the students in this group would choose the green cup?
No.
So, no. And here's where you get to actually just parrot. There is not statistically significant evidence some days I can't spell.
So we can fail to reject the null, but still say that we're not convinced?
When you fail to reject the null, you're not convinced of the alternative hypothesis.
Oh, the alternative hypothesis. Okay.
Right. You're always, in your second part, you're always going to be talking about the alternative.
Okay.
Do we find evidence for the alternative or we don't find enough evidence for the alternative? Again, back to the court trial, you start with not guilty. Is there enough evidence to change your mind? If there is, then you pronounce them guilty. If not, you say not guilty, we haven't changed our minds. Okay? I'm not going to write out the rest of it. You guys have already written the rest, haven't you?
Yeah.
Okay? Now, quick question. This was 60% of this sample said that the green cup tasted more natural. That's pretty different than 50%. Keeping the 60%, if I had found 60%, what number could I have changed in this that would have made this more convincing?
If it's 15 to 18%? Or
18 was just a number.
oh,
So I do a sample and I get 60%.
oh, the sample number. If the sample size was like 500.
Yeah, if my sample size was bigger, I'm likely to be more easily convinced.
Yeah.
The smaller the sample size is, the more it has to differ from your null hypothesis to be convincing.
Because that would change the standard deviation.
Yes, and it would make the standard deviation
A lot
a lot smaller, which would make my z-score
Bigger.
a lot bigger. Exactly. Okay. So okay. So in thinking about this, so we can't know how many people in the general population, right? But this is one of those things where sometimes people will say things like, well, our sample shows 60%, and that's way off from 50%, therefore you should change your mind. You have to be, Jesus says in Matthew, as wise as serpents, right? You can't just accept that and go, oh, yeah, that is a lot different. Because what else do you need to know?
How big the sample size is.
How big your sample was. For all I know, all they did was they sampled 10 people, and it was, 6 out of 10, which is barely over half, right?
Yeah.
But it's still 60%. Okay? So that's what you have to keep in mind. Both of those things are important. All right. So let's take a look at this one. A newspaper reports that 40% of adults in the U.S. would say that football is their favorite sport. That's what they're saying. Okay, you immediately go, on this one, it's a little easier to glom onto that. That's going to be our null hypothesis, right? The mayor of a small town wonders if the proportion of adults in his town that would say that football is their favorite sport would differ from the national average. He selects a random sample of 100 adults in his town and finds that 29 of them say football is their favorite sport. Do these data provide convincing statistical evidence that the proportion of all adults in this town who would say football is their favorite sport differs? Again, they double down on it here and remind you again, it's different, not greater than, not less than, different than. Okay? All right, so let's go through our stuff. So, first of all, it's random because
It states it in the
right.
problem.
The problem states our sample is random. And I think I told you guys about this, but I don't grade the AP Stat test, but I've heard stories of people write down random check, and I'm like, no. You have to say it. You can't just check it off.
So we'll be typing it though? Or no?
I'm not sure how you're going to be doing. I think you're going to still be writing the free response part, but I need to check into that.
And then the multiple choice will just be like.
Yeah.
So it'd be like hybrid then, like we get the free response on paper.
Yes. I think, but let me double check that. Did I send you guys the link for the practice?
Yeah.
I think so,
Yes,
yeah.
sir.
Yeah, take a look at that. That should be set up the same way-ish. The problem is that writing this, there's so many symbols and you're using Greek letters and things like that. I think you're going to be writing this part.
Yeah, I didn't even think about that.
All right, so the sample is random. What's next?
Independence.
Independence.
So less than 10%.
So we're going to check for the less than 10%. So we'll assume that 100 adults is less than 10% of all adults in this small town. So here, unlike the one for the high school, where you might get brother and sister, here you might get husband and wife, right? And if it's a small town where it's crazy inbred, you may get,
Give me both.
you could I suppose if it was in Arkansas. All right. So what's the last thing?
The success and failure rate.
Okay.
Yeah.
So our expected successes is going to be what, 40% of the 100?
Yeah.
So that's 40, clearly greater than or equal to 10. And our expected failures is going to be 60% of the 100, also greater than or equal to 10. So the assumptions and conditions have been fulfilled for A. See if you can do this without looking back.
One sample z-score?
Oh, close.
Z.
Proportion. Z score proportion. Z
I'm gonna have to look that up together.
for one sample.
One sample,
Z test for proportions.
Z test for proportions. All right, nope, not that.
So do we have to?
I forgot to minimize it again. Pardon?
Do we have to do it in percents? Like when we're doing the hypothesis and stuff? Or do we
So
do
right
that-
now, we're only doing them for proportions.
Oh,
All right. Let's start with the calculator this time and see if we can get something helpful. So I'm going to go out of this and go to inference. And it's an inference test. And notice it tells you right there the name. One proportion z-test.
nice.
Okay? So, we need to talk about our null hypothesis, don't we?
Yes,
Yeah.
sir.
So, our null hypothesis is going to be what?
Oh no. It's equal to 0.4.
Yeah, that p is equal to 0.4. So, in a moment, we're going to need to say what p is, aren't we?
Yes.
And our alternative hypothesis is going to be what?
Anything else?
Any,
Anything other than that.
so not equal.
Exactly. We don't care if it's more or less. All right, where P is the proportion of all adults in this small town who would say that football is their favorite sport. All right. Someday I'm going to remember that I have to minimize that each time. It's not today, though. All right. So we want this to be 0.4. And I want to make this not 0.4. The nice thing about this is it goes through and asks you a few things. So the first thing it asks you is the number of successes. There were only 29 out of 100. And we haven't quite gotten to this part yet, but this is saying 5%. If there's a 5% chance, right, if it's less than 5%, I'm going to reject the null. If it's more than 5%, I'm going to fail to reject the null. But the nice thing is you go down to your next, and it gives you all of those values without you having to calculate them separately.
Oh, so this is like the shortcut to what we did on the first.
Yes. So our p hat is 0.4. 0.29. That wasn't exactly a difficult thing to do. I swear to you, I'm going to remember someday. Our p-value, our z-score, is negative 2.245.
Wow.
I didn't do it again. Swear. Is 0.025, we'll call it. So that's the probability that we would get a z-score that low, right? You can talk about it in either way. What we're leading towards is ones where they're going to give us a cutoff. They're going to start saying, all right, or you make one. And we'll talk more about that in the next chapter. But with a z-score, with a p-score this low, when the p is low,
Reject the hoe.
reject the hoe. That's exactly right. All right, so with a p-score this low, we reject the null hypothesis. And find, and then we're going to just take this sentence. Convincing statistical evidence that the proportion of all adults in this town who would say that football is their favorite sport differs from 40%. And yes, I know it's a lot of writing, but you're just copying at this point.
So rejecting the null hypothesis is the H.
Right, H naught,
And then the HA, what does that mean?
that's the alternative.
Okay, so if we prove the alternative, we're not proving it, we're just rejecting it, because we're not accepting.
No, we're not rejecting the alternative, we're accepting the alternative.
Okay, accepting the alternative.
We have moved, we're like, okay, this is very unlikely to have happened this way. So we're rejecting what our original assumption was that 40% of the people in this town would say football is their favorite sport. And therefore we conclude that the proportion of adults in this town who would say that football is their favorite sport is different than 40%.
So when we explain the p-scores,
Yeah.
you could use that percent, but could we also say because it's lower than 2 standard deviations, we reject it? Is that another way of saying it?
Yes, you can. The only difficulty with that is what's going to happen is, like I said, we're going to move to ones where they're going to give you what they call an alpha level, which involves the p-score.
Oh,
So you're going to have to find what the probability is specifically.
that makes sense.
Oh.
Okay, the 2 standard deviations is kind of more of a rule of thumb than anything else. But this is pretty unlikely. There's only a 2.5% chance that this could happen if the proportion of adults in this small town who would say football was their favorite sport really was 40%. Okay, it's pretty convincing. And it's quite a lot less. Must be, I don't know, some town far north where they really, really love their hockey. I don't know. Okay. Any questions about that? Does that kind of clear up how the hypothesis test works?
Yes, sir.
All right. So let me give you back your quizzes.